Okay, so this lesson I think is pretty easy. I can model and solve problems using properties of parallelograms. So just a continuation of stuff you've already learned. Maybe you haven't learned all the properties, but you probably know a lot of them, more than you think, I would bet. Okay, so a parallelogram is a quadrilateral. Anytime you see that word quadrilateral, that just means four sides. And it has two pairs of parallel sides. So if you look at the picture, those little arrows, those denote parallel sides. And there are 5 properties that you look at when you're talking about parallelograms. So opposite sides are parallel. Opposite sides are also congruent. So like AB and DC would be the same length. AD and BC would also be the same length. Opposite angles are congruent, so B and D would be the same, and A and C would be the same. Adjacent angles, or sometimes we call that consecutive angles, they are supplementary. So A and B have to equal 180 degrees when you add them together. D and C have to equal 180 degrees. A and D have to equal 180 degrees. B and C have to equal 180 degrees. And then the last one is that the diagonals, so if I draw from corner to corner, they bisect each other. So that word bisect means cut in half or cut into 2 equal pieces. And so this is what happens. Those 2 are equal and these 2 are equal. So that's a lot of stuff to remember, but it's pretty simple, I think. Alright, and there are 3 special parallelograms that we will talk about. So a rhombus is this one down here. A rhombus has 4 equal sides, and then those same 5 properties are still happening. A square is very similar to a rhombus, 4 equal sides, but then you know that a square also has 90-degree angles. A rhombus doesn't have 4 90-degree angles. And then a rectangle has 4 90-degree angles, but the opposite sides are congruent. So those properties still hold true for these. They're just special parallelograms because they have like a few more properties involved. Alright, so here's a quadrilateral. This is not a parallelogram, but it is a quadrilateral because it's 4 sides, and this is called a kite. So here's the properties of a kite. 2 pair of adjacent congruent sides, so these 2 up here that are adjacent to each other, those are congruent, and then these 2 down here are congruent. Non-vertex angles are congruent, so the vertex will be like the top and bottom. So these 2 are going to be congruent to each other. And then the diagonals are perpendicular and they bisect the vertex angles. So if I draw the diagonals, they're making 90 degrees, and then they're also cutting this angle up here in half and cutting this angle down here in half. Let me do 3 right there. So those are the things to remember about a kite. Trapezoid. So you could also have a trapezoid that looks like this. So trapezoids have 2 pair of parallel sides. Only 2. A isosceles trapezoid, that's the first one, has non-parallel sides congruent. So the sides over here that are not parallel to each other, those are going to be congruent. In the bottom trapezoid, those are not going to be congruent. Consecutive angles between the bases are congruent. So like here and here, those angles are going to be congruent to each other. And then a isosceles trapezoid has congruent diagonals. So when I draw the 2 diagonals, they would both be the same length. They don't bisect each other necessarily, but they would be the same equal length. Alright, and then this is from middle school, but sometimes we forget it. So here is the area formula for a trapezoid. So this is what I call base 1 up here, and then base 2 would be down here. And then you also have to know the height of the trapezoid, and the height meets at a 90-degree angle. So this is not the height, that's just a side. The height has to meet the base at a 90-degree angle, just like height always has been. Alright, so here's an EOC problem. David plans on covering his floor with new material. The floor in an isosceles trapezoid has bases that are 16 and 26. So I'm going to make that longer side the 26 one and the smaller side the 16. And then the sides are 13 feet in length. Each piece of new material has an area of 2.5 feet. Assuming the piece of new material can be cut as needed, how many pieces does David need? So David is covering this floor. We have to know the area of it. If you'll notice, we don't have the height of the trapezoid. We have the base 1 plus the base 2, but we don't have that missing height. So let me use green for height. So the height is going to be from here to here, or from here to here. So here's what you could do. So the upper base is 26, the bottom base is 6. If I subtract 26 minus 16, I get 10. So that means 5 feet has to be over here, and 5 feet has to be over here. Because 16 plus 5 plus 5 is 26. So here's what I've done. Oh, that's horrible. Let me try that again. Alright, I'm going to draw this right triangle. Alright, so this length is 5. This is 13. I don't know the height, but I can use Pythagorean theorem to find it. So Pythagorean theorem says h squared plus 5 squared has to give me 13 squared. So h squared plus 25 has to equal 169. If I subtract 25 from both sides, I get 144, and then the square root of 144 is 12. So now I know what the height of that trapezoid is. I'm going to erase this just so I can have a little bit more room, but I now know that the height is 12, and I also know what the two bases are. So base 1, 26, base 2, 16, and that needs to be multiplied by 1/2. So I'm going to go ahead and find the area of that floor. I got 252. So that is the entire area. I know that each piece has an area of 2.5. So I'm going to divide that to figure out how many pieces I need. So when I divide that, I get 100.8. If I buy 100 pieces, then I'm going to have 0.8 of a foot left without a piece on it. So I always want to round up to the nearest whole number. So I'm going to buy 101 pieces to cover the entire floor. Alright, so hopefully that made sense. Okay, so here's a parallelogram. Anytime it says A, B, C, D, make sure that you are labeling the parallelogram in a circle, like either clockwise or counterclockwise. Don't go from don't do like a zigzag pattern. So I've seen some people do that. Do not do that. So it says if measure CDA, so notice that D is in the middle. So that means the angle D is my 66, if that confuses you. And I'm trying to find BCD. Notice that C is in the middle of that. So I'm trying to find this angle right here. And so from properties of parallelograms, I know that adjacent angles or consecutive angles should equal 180 degrees. So 66 plus something should equal 180 degrees. So all I have to do is 180 minus 66, and I get 114. So this angle up here has to be 114 degrees, for when I add 114 and 66, I get 180. So this diagram is not drawn to scale. Make sure you notice that. So it looks a little weird that my obtuse angle is 66 and my acute is 114, but that's because it is not drawn to scale. So don't trust the picture, trust the math is what that means. Alright, so here's a kite. We have to know some things about a kite and the properties of them in order to solve this. So it's got these little tick marks, but you should also know that the two bottom sides are equal to each other. So if you'll notice, these two up here, they are also equal to each other, but it's not going to help me any if I set a y minus 2 and an x plus 2 equal to each other. There's nothing I can do with that. So I'm going to take these two and set those equal to each other, because they both have x's in them. So very quickly, I get x equals 9. And it wants me to find the lengths of the sides of the kite and the values of the variables. So I just found 1. That's good. And now I'm going to plug this back in. So if I replace x with 9, I get that this side is 20. This side is also 20. And now I can plug the 9 in for the x and get 11 up here. So now that I know these two sides equal, I know that when I do y minus 2, it has to be equal to 11. So I can very quickly get the other variable. So there's my two variables, and I also know that my side lengths are 11 and 20. So there's actually like 4 different answers in this problem because it asks us to find the variables and the lengths. That's why we had to find all of that. Okay, so hopefully that helped. There are practice problems on haiku for you to do. You can email me, send me a message on the Remind app, whatever you need to do. Bye!